Okay, so we're back looking at section 1.7, which is the inequality section for your college algebra class. We've already talked about the linear inequalities, and it had the rule where you had to flip the inequality if you divide it by a negative, and then we talked about the quadratic inequality in the last video. We talked about how you solve the quadratic like we solve quadratics, either the factoring or formula, and then you take the solutions and they create these boundary lines that you have to check regions between. So you have to do this follow-up. Either it's in the middle of those boundary lines or it's the outside parts of the boundary line. And you have to check to figure out which one of those it is. So the last thing we need to do in section 1.7 is the fraction or the rational inequalities. And so I'm on page 156, if you're following along, there's a green box with the rules for the fraction or the rational inequalities. And the first step says you have to rewrite the inequality so that you have a single fraction on one side. So you need to get everything on one side, like we do for quadratics, you know, sort of standard form, get it all to one side. But then additionally, if there's multiple fractions, you need to consolidate it into one single fraction. So we're going to see this here on example 8. We need to bring the 1 across the line. So we get 5 over x plus 4, and now I'll make that a minus 1 and leave a 0 on the right side. So here's the hardest part about these is you have to combine these fractions. You have to combine it into one single fraction. And so to combine fractions, you have to have like denominators. And the denominator is probably just going to be this denominator that's sitting here. If you've only got one fraction, one denominator, that's going to be your least common denominator, your common denominator. So I'm going to rewrite both of these as fractions with the same denominator of x plus 4. So when I change this term, which is just a 1, to x plus 4, it's just going to be x plus 4 over x plus 4, right? Because anything divided by itself makes the 1. That is another form of the number 1. So, and I chose it to be x plus 4 just because that's the thing I had in the other fraction, and I wanted them to match up. So I'll make that 1 the same thing with x plus 4's on the bottom. And now that'll allow me to consolidate that into a single fraction. So once I have a like denominator of x plus 4, you can combine across the numerators. So it'll be 5. Now watch this though, because it's subtract. That subtract will distribute into the fraction. It makes that a negative x, which is maybe a little more obvious, but it also distributes here. It makes that a minus 4. So watch out for that. So then you've got a 5 and a minus 4, which is 1 minus x over x plus 4. All right, so that's step 1. Like I said, that's really the only hard step of this last type of inequality. You've got to consolidate to a single fraction. Some of your homework will already be a single fraction, and you won't have to do step 1, so it won't be bad at all. But if so, that's step 1. Step 2 is you set the numerator equal to 0 and the denominator equal to 0. Instead of like factoring, you have two factors. Here you have a top and a bottom to set equal to 0. So we set our numerator, 1 minus x equal to 0, and the denominator, x plus 4 equal to 0. And then solve those two mini equations. This one, we throw the 1 across the line, divide by negative 1. We get x is 1. And then for this one, x is negative 4. So we solve, we get our two solutions. And then just like what we did in the last video, those create regions. It cuts the number line at negative 4 and at positive 1. So it cut the number line with these solutions that you found. You found two solutions, really. What makes the numerator equal 0, that naturally solves this because 0 divided by anything is 0, so it's going to give you the what makes the numerator of that fraction I consolidated. That solves it. And then the denominator, the reason it's important in fractions is you can never have a 0 in the denominator. So we have to see what makes the denominator equal 0, because that's actually a bad thing. You cannot have a 0 in the denominator of a fraction. So that'll be a boundary that makes the graph have a stopping point. Something we're going to study later when we're graphing, it actually is called an asymptote. And it's a line that the graph can't kind of make peace with because it's not defined. Dividing by 0 in math is undefined. So it's a place in the graph that the graph's kind of confused. It's like, what is this? This isn't even math. So it divides the number line or cuts the number line and makes a stopping point or a boundary for it too. So our solution we got of 1 for what made the numerator equal 0, and then our what made the denominator equal 0, which is like a no-go stopping point for the graph, cuts it there as well. Alright, but regardless, there are 3 regions, just like we saw in the last video. So we take a test point to see if it's the inside or the 2 outer regions, or really, you could just test all the regions to see. But I'm going to test the 0 and see if it solves the original inequality, because that's really what we're trying to do, find what solves this inequality. So let's plug in 0 for our x and see if this is true. 5 over 4, that would reduce to, is that greater than or equal to 1? 5/4 is more than 1, it's 1 point something, so it's more than 1, so yes, true, true. So everything else between -4 and 1 should also be true. So that's what we're going to shade. To be thorough, you could take like -5, check it, make sure it doesn't work, and then also check something past 1 over here and make sure. That is the method shown in the book, to just check every region. But I'm going to say we did, and we found this is the only true region. So the solution is between -4 and 1. But here's the thing. We cannot, even though there's a line under it, we cannot use a bracket on -4, because like I mentioned before, -4 cannot be included in the solution. If you plug -4 in for x, -4 plus 4 is what makes this denominator equal 0, and will give you a big error reading on your calculator. Plus it just isn't math, it's undefined in math, so it cannot be a solution. So even though there's this line under it to say use brackets, this is kind of that exception to the rule. We cannot include the boundary that made it undefined, because it can't be part of the solution. Now the 1 is fine. The 1 is what made the numerator equal 0, and that is okay in math. So we actually have one of each, a parenthesis for the boundary at -4 and a bracket for the boundary at 1. Alright, so lots of little details in that. Let me give you a you try now to pause the video and try on your own. So your practice problem is 6 divided by x minus 3 greater than or equal to 4. Now I'm going to proceed with this though, and as soon as you stopped and came back in. So the first step is consolidate by bringing the 4 across the line and get a single fraction. So when we do that, we've got to get a common denominator, and it's usually just whatever this other fraction was of x minus 3. So we're going to write both of the fractions with a denominator of x minus 3. So how do I do that? Well, if you thought of that as being 4 over 1, you would say this 1 has been changed into x minus 3, so I also have to times the top by x minus 3. It's like you just times the top and bottom of the fraction, the existing fraction. You add an x minus 3 to top and bottom of it, and you kept its balance on there. So we're going to add an x minus 3 by our 4, and would you agree those would cancel right back out, and it's equivalent to what it was before. So we've just balanced the top and bottom of this fraction with this denominator that we needed. Now that we have a like denominator of x minus 3, we're going to combine the numerators. We've got 6. Watch out for these subtracts because they distribute. So minus 4x, and that'll make a plus 12. Then 6 and 12 combines to be 18, and then minus 4x over x minus 3 greater than or equal to 0. So now you've got one single fraction. And then step 2 said set the numerator equal to 0, so 18 minus 4x equal to 0, and the denominator, x minus 3 equal to 0. And those will be our 2 cutting points along our number line, where we'll check regions. So this one's the easy one, x equals 3. Also keep in mind, x equals 3 is the number that makes the denominator equal 0, so we cannot include it in the solution. Now the numerator, we can. We throw the 18 across the line. We throw it over there. You'll have negative 4x equals negative 18. Divide both sides by negative 4. Sorry, I scrunched that in there. It'll make it positive 18/4. But let's reduce that because both of those are even. Could reduce to 9 over 2. So the other boundary is at 9/2. You can write it as a decimal if you're thinking that, but normally the more exact answer we leave as a fraction. unless there's decimals in the original problem, usually they want a fraction is a better, more exact answer. So our two boundaries are at 9 over 2, which would be, what, 4 1/2, and then at 3. So the 9 over 2 is bigger. It belongs over on this side. We need to make sure we get those in the right order. We've got a boundary at 3, a boundary at 9 over 2. Both of those are actually positive numbers, aren't they? So I need to, if I'm going to use 0 as my checkpoint, I'm going to have to go all the way over there, right? So if I check the 0 point back in the original problem, I'm saying, is 6 over 0 minus 3 greater than or equal to 4? Let's see, that's 6 over negative 3, which is negative 2. So the question is negative 2 greater than or equal to 4? It is not, so that region is not true. Don't shade there. So this region probably is. Now, what's a number between 3 and 4 1/2? Like 4 maybe, right? So let's say I check the number 4 in the original problem. So I put 4 in for x. I have 6 over 4 minus 3. 6 over 4 minus 3 would be 6 over 1, or 6. Is 6 greater than or equal to 4? Yes, it is. So that one checks out. It works. And then to save time, I'm not going to check here, but you would check like maybe with 5 or something. But you're seeing a pattern. It's either the inside or the two outsides on all the problems we've been working, but the checking of each region is to be absolutely sure and thorough. All right, so the middle region is the region that's the solution set from 3 to 4 1/2. And what about those parentheses and braces? Because there's a line under it, it makes me think I should use the brackets, I should say. I should use the cornered one to include the solution. But I can never include the boundary for the denominator. So because x equals 3, because a 0 denominator, it's undefined, I cannot include that boundary. So I use a parenthesis regardless. Now, when I can, though, for the other solution, I use the cornered one, the bracket. So the solution is from 3, comma, to 9 over 2 with a bracket for that in interval notation. All right. Hope that helps. I think we'll cut it off there. And that's really, those are the steps. There's other examples. There's another example if you want to just read the one in your book to get another look at one. Go through. Example 9 does this as well. But that is the procedure for any fraction inequality. You consolidate it into one single fraction, then set numerator and denominator equal to 0, and then check each region. All right, hope that helps.